All right, section 6.2, evaluating logs. So here we're all looking at evaluating using these logarithmic functions and exponential functions to kind of help understand them a little bit better. The first section we're going to start with, we should already know how to do pretty much all of these based on our last unit. So if we have 4 to the power of 3, then we should know that that is, we'd have, a base of 4, an exponent of 3. So this would be 4 times 4 times 4, and that equals 64. Right? None of that should be new to us. So 4 to the power of 3 is 64. 5 to the power of 4 would then be 5 times 5 times 5 times 5. Let's see, that should be 125 times 5 is 625. Okay, 9 to the power of 1/2. We've got to remember our exponent rules where we have the fraction as the exponent from our last unit. Remember that would be the same thing as the square root of 9, which would then be 3. So then similarly, 343 to the power of 1/3, we would be then looking for the third root of 343. So we're looking for something that's being multiplied times itself 3 times to get to 343. And that would be 7. 7 times 7 times 7 is 343. And so the cube root of 343 equals 7. Okay. Next one did give us a little bit more trouble when we were doing the quiz, at least. But 4 to the power of -2, that would be the same as 1 over 4 to the power of 2, because remember the negative exponent puts that to the bottom of our fraction. So then that makes it simple from there. 1 over 4 to the power of 2 would be 1 over 16, because 4 squared is 16. And then finally, 10 to the power of 3 would be 10 times 10 times 10. 10 times 10 is 100, times 10 again is 1,000. Okay. So again, all of those are ones that we should have known from before, but maybe it was good to have a little refresher on. For the bottom section, we are going to be evaluating the logarithmic expressions. So here we have log base 2 of 8. Log base 2 of 8. And what we were looking at earlier, we had logarithmic equations. So we had our log with a base of something, and then it was equal to x. Okay. When we're trying to evaluate these logarithmic functions, we can think of them as if they were an equation to help us to find what they equal. So if we have log base 2 of 8, we want to know what it equals. We'll say that it equals x, just like we would have here in our equation. So for all of these, we could say that they equal x. We're trying to evaluate to find out what they equal. So then we use our circular relationship. We say that it's 2 to the power of x. 2 to the power of x should equal the thing that we are taking the logarithm of, which in this case is 8. So we know we have 2 to the power of something should equal 8. So essentially what we're asking is how many times do I need to multiply 2 together to make it equal 8? And that is 3. If we take 2 times 2 times 2, that is 8. So the exponent here would need to be 3. And so that is the x that we are looking for. Right? Log base 2 of 8 is 3 because we would need to take 2 to the power of 3 to make it equal 8. Okay. So that's what we're doing essentially for all of these. So for the next one, we have log base 6 to the power of x. So we'd have 6 to the power of x, the thing that we don't know. And then we want it to equal 36. We're thinking about what exponent would we need to have to make this be true. What do we need to have x equal to make 6 to the power of x equal 36? Well, in this case, that is 2. Because 6 times 6 equals 36. We would need to have 2 6's multiplied together to equal 36. And so that gives me that x equals 2. 2 is the number we need to put in that exponent. Okay. On to the next one. We've got log base 16 of x, and it needs to equal 4. And so we should have 16 to the power of x, and it needs to equal 4. So this one might give us a little bit more hesitation because we think, wait, if I do 16 and I multiply it times another 16, that's not going to give me 4, it's going to give me a bigger number. So it's not going to be able to be a number like 2, 3, 4, because if we keep multiplying 16s, we're never going to get to 4. So we have to kind of think a little bit more outside the boxes for this one. We can't use a number like 2, 3, 4, 5, positive or a whole number here. We need to think about what kind of an exponent would make our number get smaller. And we can look at some of our examples above to help us out. We have 2 examples up here where our number, our base, ended up getting smaller after we applied an exponent. Right, we did 9 to the power of 1/2, that equals 3. 343 to the power of 1/3 equaled 7. So if we are trying to take our base and make it a smaller number, like we are for 16, we want to make it 4, we're going to need to have a fraction as our exponent. All right, something like 1/3, 1/4, 1/2, something along those lines. Okay. So essentially what we're asking is what root of 16 do we need to take in order to make it equal 4? And in this case, it is the square root. Right? The square root of 16 equals 4. And so that means that x has to be 1/2. Right? Because if we put that 1/2 in here, 16 to the power of 1/2, that would be the square root of 16, and that would equal 4. So 1/2 is the exponent that we need. Okay, on to number 4. On number 4, there's one thing that we need to note. Here it says log of 100. And you might notice we are missing something. We don't have a base. There's no base written down here. When you are working with the logarithm, if there is no base written, there is a kind of invisible or an implied 10. Log base 10. So if you don't see a base written, it is a 10. So in this case, it would be 10 to the power of x that we need, and it should equal 100. So we need to know what power of 10 would equal 100. Well, 10 times 10 equals 100. And so we need 2 10s to multiply together. That gives me 2 as my answer. For number 5, we'll say that it should equal x. So 3 to the power of x should equal 9. 3 to the power of x should equal 9. So what power of 3 makes it equal 9? Well, that would be 2, because 3 times 3 is 9. Okay, on to number 6. We've got log base 2, and that would be to the power, again, of x. All right, if we put our equals x on there. And then it needs to equal the 1/8. 2 to the power of x needs to equal 1/8. Okay, so here our base gets turned into a fraction. We had 2 as our base, and it gets turned into a fraction. So, you may already know what kind of exponent we need, but to help out, let's look back above. The one that we got that resulted in a fraction, the exponent that we had was a negative. So if our base turns into a fraction, then we should know that our answer is going to be a negative number. This needs to be a negative exponent. in order to make it into a fraction. Okay. So essentially, we are looking at what power of 2 would make it be the 8 on the bottom, and then we'll just make it negative to turn it into a fraction. So if we have 1, let's see, we have 2 to the power of x equals 1/8. If it was negative, the 2 would go to the bottom, so we could say it's 1 over 2 to the power of x. And I want to know how many 2's I would need to multiply together on the bottom to make that bottom part be 8. And that answer is 3. We need 1, 2, 3 2's on the bottom. And so we are going to say that it is negative 3. Negative in order to make it turn into the fraction, and then 3 to take the 2 and turn it into 8. Okay. Last, we've got number 7, log base 125 should equal, to the power of x. So 125 to the power of x should equal 5. So here's another example where our base ends up being a smaller whole number here. So the 125 gets smaller. If you remember, that means that we need to have a fraction as our exponent. So we need to know what root of 25 would equal 5 to make it a fraction. All right, so we need to know what root of 125 would equal 5. It's not the square root. It is the cube root, because we would need 3 5's multiplied together to make it be equal to 125. So it is the cube root that we need, which means it needs to be 1/3 as our exponent. Right? Our exponent needs to be a fraction in order to make it get smaller. And we need the 3rd root, and so our exponent is 1/3. Okay, 2 more. Number 8, we'd have 6 to the power of the x should equal 1 over 216. So again, just like number 6, we know that this is going to have to be a negative. So our answer is going to have to be a negative number in order to make it into that fraction. And then we basically just need to know what power of 6 would be 216. So let's see, 6 times 6 would be 36. If we multiply it times 6 again, that gives us the 216. And so we need 3 6's multiplied together to get the 216, and it needs to be negative to make it be a fraction. And so this one again is going to be negative 3. All right, last one. We have log base 11, again to the power of x. So 11 to the power of x is going to equal 121. So this one's kind of back to our more normal ones, I guess you could say, where our base gets bigger after we apply the exponent. So we just need to know how many 11's multiply together to make 121, and that answer is 2. If we take 11 times 11, that equals 121, and so we need 2 11's being multiplied together. That makes our exponent 2. So that is the end of our notes for 6.2. You should be able to now complete the 6.2 practice. And once you are done with that, then you are done for today, and I will see you all tomorrow.